Alrighty, in this video we are going to be talking about polar graphs in terms of pre-calc, and then eventually this will lead us into area of polar graphs and tangent lines of polar equations, so that's going to be a lot of fun. Alright, so for number 1, 2, and 3, these are going to be your basic simple ones that you won't see on the AP exam, unfortunately, but it is going to be helpful for us to understand why these graphs are the way they are. So for example, whenever I have number 1 that says sketch r is equal to 2, where I don't have theta right here, because remember, my representation is r comma theta, then I'm just going to go to 2, so 1, 2, and then because I don't have theta, theta could technically be anything, and since theta can technically be anything, this is going to give me a circle with a radius of 2. Now let's think about why this makes sense in terms of, let's say, using rectangular coordinates. Because remember that r, r square, let me say that, r square is going to be the same thing as x squared plus y squared. And if I'm squaring r here, this means that my radius is going to be 4. Or my r squared is going to be 4, which means that my radius is going to be 2. So I have x squared plus y squared, which is r squared. And then if I'm doing that, then of course I'm going to have to square r to get 4 right here. Okay, number 2, I have theta is equal to 5 pi over 4. For this one right here, since I don't really have an r value, my r value can be anything, except I just want my theta value to be 5 pi over 4. So I'm going to go to 5 pi over 4, graph that line, and then I'm also going to graph the line opposite to it to get this lovely line at 5 pi over 4. For number 3, whenever we want to sketch 3 secant of theta, let's probably convert secant of theta into something that we know. Let's say 3 over cosine of theta. And that is r cosine of theta is equal to 3. And we know that r cosine of theta is x. So x is equal to 3, meaning that I'm going to have a vertical line at essentially 3. Right there. Now, for number 1 and number 3, we converted my polar equation into rectangular coordinates. So x is equal to 3, and then x squared plus y squared is equal to 4 to verify my answers. Sometimes that won't be the case just because your polar equation might look wonky. But number 4 and number 5, we can probably do this using rectangular coordinates, so we're going to convert this, and then later on we'll see that like number 6 through 12, we'll just use polar coordinates for those. So for number 4, we want to sketch r is equal to 4 cosine of theta using a table. Okay, so what I'm going to do here is multiply by r by both sides. I know this is using a table, but I'm going to use the rectangular version of this. So r cosine of theta. So then I have x squared plus y squared is equal to 4x. I have x squared, I have 4x, and I have y squared. So let's think about it this way in terms of, hey, maybe we need to complete the square to figure out what my center is going to be and what my radius is going to be. So now if I do that, I'm going to have, well, let me not confuse you. Now I'm going to have x squared minus 4x plus blank plus y squared is equal to 0. Complete the square, I am going to get 4 right here. So now I have x minus 2 squared plus y squared is equal to 4, which means that my center is going to be at 2, 0. Now, this tells me that I have a radius of 4, so what I'm, not a radius of 4, a radius of 2, so I'm going to go right 2, left 2, and then try to do 2 units down. This one's going to be the hard part because we don't really have R values of us going vertically. But, you know, try and see where that takes us. Well, as long as it makes a circle, you'll be fine. Ooh, that is not pretty. There you go. And that right here is your rectangular or your polar graph of this based off of my rectangular equation. Now let's say that we don't want to do that. So let's say on number 5, we want to actually use a table. What I'm going to do is go ahead and figure out my theta values for 0, pi over 6, pi over 4, pi over 3, pi over 2, and so on, and see what happens there. So here I'm going to have 4 sine of 0, and that is just going to be 0. If I have 4 sine of pi over 6, that's going to be 4 times 1/2, which is going to be 2. So at pi over 6, I'm going to have 2. Okay. And then at pi over 4, I'm going to have 4 times root 2 over 2, which is 2 root 2. Use our handy dandy calculator to figure out what 2 root 2 is, and that's going to be 2.82. So that means at pi over 4, I'm going to have 2.82-ish. So 1, 2, 2.8, so something like that. Right there. At pi over 3, I'm going to have 4 times root 3 over 2. And that right there is going to be 3.4-ish. So I'm going to have 3.4. 1, 2, 3, 4. And then at pi over 2, I'm going to have, of course, 4. Okay. Now what we're going to do essentially is going to be doing 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. And hopefully you'll notice that because this is sine, that this is going to be essentially my y values right here still. And still going to be positive. So I'm going to use a little bit of symmetry going on here to get these values for 2 pi over 3, 3 pi over 4, and 5 pi over 6. That's just like 2.8. Yeah. That gives us my circle that you'll see right here. Oh, I know it's not pretty, but you know, it is what it is. You also might notice something very special about 4 and number 5 is how here for number 4, if I have a cosine right here, it's going to make a circle with my radius being across the x-axis. And for number 5, since we have sine, notice how my radius is going to be across my y-axis. So that's something to think about. All right. Number 6 here says, Sketch the graph of the polar equation r is equal to 1 plus 3 sine of theta by sketching r in rectangular coordinates. So here, this is going to be another representation where we're not going to be using rectangular coordinates and converting this or making a table. Here, number 6, I'm going to sketch r. So that means that I'm going to sketch the sine function as a regular schmegular rectangular equation. So here, let's say that this is y is equal to 0. You have 1 being your midline. And then you also have your max at 4. And then your min at 2. Okay, so we have, let's say, 2 pi right here. We have pi right here. We have pi over 2. And then we have 3 pi over 2. What we're going to do is just graph this. We know that sine starts at the midline, then goes up, then goes back to the midline, then goes down, then goes back up to my midline. So now we have this graph right here. Okay, so here's what we're going to do. Based off of my rectangular graph right here, we're going to convert this into a polar graph. Notice how at 0, we are starting at 1. So here, I am going to start at 1 right here. Now, you'll notice that from 0 to pi over 2, we are increasing. So as my theta increases, my r value will also increase. And this means that pi over 2 is going to be at 4. So 1, 2, 3, 4. So my r values are increasing. In addition to that, my theta values are also increasing. So if I were to think about this, it should look something like, let's say, this right here. Oops, that right there. So you could see that my r values are increasing as my theta values also increase. We're going to do the same thing from pi over 2 to pi. You'll notice that as my theta increases, so my theta increases right here, my y value, or in this case my r value, my radius is going to decrease. So now it's going to look something like this, where I am decreasing, and I'm going to be at 1. So here, I'm going to do this in blue. It's going to look something like that right there. Now, here's something important to note. You'll notice that from pi to 3 pi over 2, we kind of have a 0 right here, and we don't know what the 0 is technically is, but we do know that from here to here, we are decreasing. So from pi to whatever this interval is, we're decreasing until we hit 0. So here, as my theta values increase, I'm going to be approaching 0. So now, that part looks like, let's say, this right here. So I'm going to maybe clean that up a little bit. And then from this point to 3 pi over 2, we are down at -2. Now remember that we don't have negative r values, so what we are going to do from pi to 3 pi over 2 is make this a positive 2. So at 3 pi over 2, if we have this right here, it's going to be up here. 1, 2. Let me use a different color. So 1, 2 right here. And since I am decreasing right here, I'm technically going to be increasing just because I'm going to be adding pi here and pi here so that it looks like, let's say, this right here. Okay, now from here to here, we have something between 3 pi over 2 and 2 pi, and that's going to be 0. So, we're going to do the same thing where I am decreasing. Now, why am I decreasing even though this is increasing? Because remember, I have an R value of -2, so that's going to flip everything. Now, it's going to look like this. And then from that to 2 pi, I'm going back to 1. In this case, because I am above the y-axis now, and this is positive, I know that this is still going to be positive. So that's going to be this right here. So that is your lovely graph. Now, what I'm going to do also is actually graph this on Desmo so that you could see how that looks like. So 1 R is equal to 1 plus 3 sine of theta. Oops. Make this into a rectangular grid and see how we kind of graph this from, let's say, what was our thing? Like -5 to 5? Yeah, so it kind of looks like that lovely thing right there, which is what we drew right here. Mine isn't the best, but you know, it is what it is. Okay. Number 7, what we're going to do is sketch the graph of the polar equation by substituting in values. So this one here, we're going to go ahead and substitute in values. What I want you guys to do is go ahead and pause the video, substitute in the values, and then what we're going to do together is essentially graph this together. Okay, so hopefully you got these as your lovely coordinates. They should have been quick, even though they were a lot. Here, we are going from 0, 4, so 1, 2, 3, 4. Then at pi over 6, we are at 2. At pi over 4, we're at 0. And then at pi over 3, we are at -2. Now, at pi over 3, even though we're at -2, that means that we're going to have 4 pi over 3, since this right here becomes this right here. So what I'm going to do is go ahead and sketch that first part. So we have this right here, and we have this. Now, at pi over 2, we have -4, which is going to be a +4, but then it's going to be in the opposite direction. So instead of a pi over 2, we're going to have a pi over 3 pi over 2. 1, 2, 3, 4 right here. Same thing with the 2 pi over 3. Because we have a -2, that's going to give us 5 pi over 3 at 2. And then at 5 pi over 6, we are back at, well, at 3 pi over 4, we're at 0. And then at 5 pi over 6, we're back at +2. So that's going to give us that right here. So now we have this right here. And hopefully you could see what's going on here, because then at pi, we're at 4. At 7 pi over 6, we're at 2. And then at 5 pi over 4, we're at 0. And then at 4 pi over 3, we're back at -2, which then becomes pi over 3. At 3 pi over 2, we're at negative 4, which means that pi over 2 is going to be 4. At 5 pi over 3, we have negative 2, which means that 2 pi over 3 is going to be positive 2. 7 pi over 4 are at 0, and then 11 pi over 6, we're at 2. And then, of course, we go back to 2 pi, which is at 4. So it makes this lovely graph right here. All right, I'm gonna do one more. Let's see, what did I do here? That's a sine. So let's do a cosine one. Let's see 11. 11, we want to sketch the graph of the polar equation r is equal to 3 plus 2 cosine of theta. So what I'm going to do here is work with this in terms of my rectangular graph. If you want to substitute in values, you can. It's just what you want to do. Okay, so with 3 plus 2 cosine of theta, I have a midline at 3. Let's do this. A midline at 3, a max at 5, and then a minimum at 1. Notice how we're not going to have any negatives here, so unlike number 6 here, we're not going to be doing the opposite here. So whenever it says increasing and decreasing, we actually mean that it's increasing and decreasing. 2 pi, pi over 2, and 3 pi over 2. Now cosine starts high, so I'm going to start high, then go down to my midline, then minimum, then midline, then back up. So I have this right here. This tells me that at 0, r is going to be 5. So right here. And then from 0 to pi over 2, pi over 2 is going to be 3. So 1, 2, 3. And notice how here, as my theta values increase, my r values decrease, which tells me that I am going to be decreasing. So it should look something like that, where I am decreasing. I know it's not pretty, but we'll look at the Desmos version of this. Okay, then from pi over 2 to pi, at pi I'm at 1. We are still decreasing. So I am going to have something like that. From pi to 3 pi over 2, we are increasing until we get to 3. So at 3 pi over 2, we have 3. 1, 2, 3. We're increasing. And then from 3 pi over 2 to pi, we are going back up and we are increasing. So it looks like, okay, that lovely thing right there. The Desmos version of this, because this obviously is not the prettiest, is going to look like 3. Let's see, that's a 2. So 2 cosine. Two cosine of theta, and then plus 3. Looks like this lovely thing right here. Very pretty, I know. All right. In the next video, we are going to be talking about tips and tricks on how to sketch these without obviously doing this by hand and plotting coordinates 24/7. On the AP exam, they will either give you the sketch of the polar graph, or it might be something where you don't really need to see the polar equation. However, it might be helpful to see the polar equation just so that you know where the tangent lines are and whatnot, so that you can verify your answers.